So, good morning, dear students. Myself, Dr. Lingaraju, Department of Physics, Government First Degree College, Tumkur. So, today we will discuss Fourier Theorem. This topic is in 4th Sem Physics, belongs to Tumkur University syllabus. So, today we will discuss Fourier Theorems. So, Fourier Theorem states that a periodic motion can be represented only by periodic functions. Certain periodic functions may not be simple and cannot be represented any sine or cosines. That means any finite single valued periodic function, either continuous or having a finite number of points of ordinary discontinuity, can be expressed as a sum of numbers of sinusoidal vibrations. That is a simple harmonic. Having a frequencies as integral multiply of a given simple harmonic vibrations. So, in mathematically, so we are going to explain the Fourier theorems. It can be explained using in this order, that is, any finite single valued periodic function, either continuous or having a finite number, of points of ordinary discontinuity can be expressed as a sum of sinusoidal vibrations, having a frequencies as integral multiply of a given simple harmonic variations. So, it is expressed in the order of a series, that is, y is equal to f of omega t. So, f of omega t, that is equal to a naught. So, a naught is a constant values of sine functions. A naught plus a1 sin omega t plus a2 sin omega t, a3 sin omega t, like that am sin omega t. Similarly, b1 sin omega t, b2 sin omega t, b3 sin omega t, like that bm cos omega plus m omega t. Where we know why. It is a displacement of a complex periodic variations of a frequencies omega. A naught constant, A1, A2, A3 of AM, B1, B2, B3 of BM are amplitudes of a sine and cosines functions. Now here we are also going to express this concept in a y. So y as a wave functions of f of omega t. That is, we can written as the previous equation here written as using the summations a naught plus summation of m is equal to 1 to infinity am sin m omega t plus sigma of m is equal to 1 to infinity bm cos omega t. This series is known as Fourier series. Here the a naught, am, bm are the coefficients of Fourier. Okay, Fourier coefficients. Now here the Fourier analysis we are going to express using a sawtooth wave. So sawtooth wave considers a waveform as shown in the figure. Let us ns is equal to a. The amplitude ns is equal to a, that is amplitude. So this one is from here to here. Also y is equal to a. Y is equal to a. That is also the amplitude line. Y is equal to a. This one is. T is equal to 0 time. Time t is equal to 0. Then y is equal to O. If t is equal to 0, y is equal to is equal to t. You can also express this y a ಆಯಿತು ಅಂದರೆ at t 0 ಆಗಿರುತ್ತೆ. y a ಆದರೆ t 0 ಆಗಿರುತ್ತೆ. y is 0 ಆದ್ರೆ so t is equal to capital T ಆಗಿದೆ. So like that here we are going to express using this sort of way where we repeats after t is equal to t. Take any point of p of t and on the line nq. Okay, next. So continuation of this mathematical expressions we are written from the similar triangles of ncq and por. So in the previous diagram we can observe ncq, then por. So these two are we can represent as a triangles. So ns by np is equal to sq by rq. But from the above figure, ns is equal to a amplitude, pr is equal to y is also amplitude, sq is equal to t, then rq is equal to t minus 1, the reference. So like that here we have the reference. After knowing the substitution of these values, so we are getting a y is equal to a of 1 minus t by t. So next is consideration of Fourier series in a sawtooth wave. Here we can explain these equations in this order. Y of t is equal to a naught, that is a constant of a, and plus sigma of m is equal to 1 to infinity am sin of omega t plus sigma of m is equal to 1 to infinity bm cos of m omega t. Then where the Fourier coefficients are given by, so a naught, so we can use it that particular previous equations. Amplitude a naught is becomes to 1 by t of integration of 0 to t y dt. Am, that is the increment values, 2 by t integration of 0 to y sin of m omega t. Then b of m is equal to, that is also one small increment value, 2 by t of integration of 0 to t y cos m omega t dt. So then after knowing this one, the analysis of the sawtooth wave mainly involves the calculations of the Fourier coefficients of am, bm and a naught constants. So Fourier first now ಮೊದಲನೇ ತಗೋಣ a naught. Fourier coefficients a naught is equal to substituting of y from the previous equation 2. Then a naught is equal to 1 by t integration of 0 to t, 1 minus t by t dt. Then substitution of all these values we are getting a naught is equal to a by 2, the amplitude of half of the amplitude. Then coefficients of next am is given by a naught I figure am, second one, half amplitude, that is am is equal to small increment value, it is a varied increment value, t 2 by t integration of 0 to t y sin of m omega t. Substituting y from the equations 2. Here y is varies. M is equal to 1 by t integration of 0 to t a of 1 minus t by t sin m omega t. Then next is am I2. Next to, after knowing that, we are knowing am is equal to adding of these values minus 2a by t square 0 to integration of 0 to t sin omega t. Then the above equation can be integrated by parts using this formula, yaudu uv. Knowing this one, so we can write it this equation in this order. Am is equal to minus 2 by t as it is a by pi m. Then where m is equal to 1, 2, 3 values, varied value, we get a1 is equal to a by pi, a2 is equal to a by 2 pi, a3 is equal to a by 3 pi. So like that it is going to variation tables for Fourier coefficients of bm. Next, third one, bm is equal to 2 by t integration of 0 to t y cos m omega t upon dt. So next, but here we know y is equal to a of 1 minus t by t. Knowing this concept, so bm is equal to 2 by t integration of 0 to t y of 1 minus t of t comes. So substitute these values, we are getting a minus of 2a by, same as the bm by pi. After integrating by parts, so we are getting bm is equal to minus of 2a by t square of t into 0 minus 0 after per limit and lower limit applying all these values. So we are getting these equations. Therefore, Bm is equal to 0. Substituting the values of quotients A0, Am and Bm in the Fourier series. So y is equal to a by 2 plus sigma of m is equal to 1 to infinity a by m pi sin m omega t. So knowing these equations, next the addition of successive terms of a series as shown in the figure. Just we can observe here. The curve confirms that this one and this peaks. Okay. The series is converging as more terms are added. Is one term, here 3 terms, here 7 terms, here 30 terms. Like that here we can observe the differences. And the curve under the analysis becomes closer. The sawtooth waveform is found in the ripple voltage of a rectifier and in an ideal time-based arrangement. Now, Fourier analysis of a square waves. Now here we are going to consider physical quantity which varies periodically in time in the form of square wave as shown here below figure. See, the physical quantity will be going to variation like the square waves. So this square wave will be going to varies the values of in the above figure the complex function y as a constant value of a. At t is equal to 0, t is equal to t by 2. Y is equal to 0, therefore the y can be written as. Like that here we are going to say y is equal to a for 0 less than t by 2. Y is equal to 0 for t by 2 less than t minus 2. This is given by y of t is equal to like this. A0 plus sigma of m is equal to 1. Am sin omega t plus sigma of m is equal to 20 into t Bm sin omega t. That is already we know it from the equation 1. Now, where Fourier coefficients are given by A0, you can have calculated Maduro value 1 by t of 0 to t yt, 2 by t of 0 to t y sin omega t dt. Bm is equal to 2 by t of integration of 0 to y t y cos m omega t of dt. So, what the equation 1 previously discussed, it is written as applying all these values. Like here we are writing these values. So next is Fourier coefficients of A0 is given by. So A0 here ನಾವು substitute ಮಾಡಿದ್ರೆ, so above the two parts we can get it. A0 is equal to 1 by t of 0 to t2 y dt plus 1 by t of integration of t2 y dt. So next step, knowing this concept, we know y is equal to a when t is equal to 0, t is equal to t by 2. If y is equal to 0 in the graph we can observe ಅದು ಎಲ್ಲಿ ಪೀಕ್ ಇರುತ್ತೆ ಇಲ್ಲಿ 0 ಆಗಿರುತ್ತೆ. ಆವಾಗ the time intervals of t small t is equal to capital T by 2 and small t is equal to capital T. So knowing these two equations, the A0 equation of wave function is becomes to 1 by t integration of 0 to t by 2 a dt plus 1 by t integration of t by 2 of t 0 t is equal to 1 by t integration of 0 to t by 2 a dt plus 0. That is equal to 1 by t integration of 0 to t by 2 a dt. Then continue, this one is A0 is equal to 1 by t of a of. So integrate all these things, we are getting a finally a by 2. Of knowing A0, the Fourier coefficients of am coefficient, next am is equal to 2 by t integration of 0 to t a sin omega t. Now we can split the same integral into two parts. So even as two parts I integrate am is equal to 0 to sin a sin m omega t dt plus 2 by t 0 to 2 of t2 sin omega t dt. T2 extra is there. Okay. And next is but y is equal to a when t is equal to 0 and t is equal to t by 2, y is equal to 0 when t is equal to t by 2, t is equal to capital T. Like that, then the equation becomes to m is equal to 2 by t integration of 0 to t by 2 a sin m omega t plus 2 by t by 2 a sin omega t dt. Knowing these equations, you are getting these values. That is a sin omega t, then this am. If m is a even integer, then cos of m pi is equal to -1. If m is an odd integer, then cos of m pi is equal to plus 1s. Then we can write it. These equations, am is equal to minus of a by m pi 1 minus of 1 to the power of m. Now for these equations, if m is equal to 1, what happens? 2a by pi. If m is equal to 2, what happens? a1, this becomes to 0. If m is equal to 3, so it is equal to 2a by pi. M is, so it seems to be, so in the odd and even numbers, the amplitude of a wave function will be going to varies in a Fourier coefficients. Then similarly, Fourier coefficients Bm is given by Bm is equal to 2 by t integration of 0 to t y cos m omega t dt. Then we can split it into two parts as like am constants. So we are getting these values. So here also we are going to split it to get the values of Bm is equal to 2 by t a of sin m omega t by m omega of 0 to t. So now substitute the values to get the Bm is equal to 0. When m is equal to 1, 2, 3, we get b is equal to 1, b2 is equal to 2, b3, so it comes to 0. Substitute the values of a1, a2, a3, b1, b2, b3, and in equation to get equation 2 now it is going to becomes y is equal to a by 2 plus 2a pi sin omega t amele b gote 0, then sin omega t plus 2a by 3 pi plus 0. So like that here we are getting. Substituting of all this, adding of this one, y is equal to a by 2, then 2a by pi sin t. So these are all there separated and plus with other signs. So next here we are getting these equations. Y is equal to a by 2 plus 2 by sin of 2 pi by t, 1 by 3 sin of 6 pi t by t, 1 by 5 sin of 10 pi t by t. Then omega is equal to what? Frequency 2 pi by t. Then so here we are getting the figure shows formation of a square waves. The formation of a square waves due to the addition of first three terms in Fourier transformations 1, 2, 3. So adding of these three, first form, third term, first term. This is the first, fifth, this is the third, this first. So the combination of all these terms will be one square wave. The resultant of these values here we are getting a square. That is, we can observe from these diagrams. Formation of a square wave is due to the addition of first 15 terms in square waves. 15, that is at the graph of y is equal to a by 2, t of and t. So we can easily observe the variation of a square waves in a Fourier series. Next, so after knowing this concept, so we can explain about the Fourier coefficients. It's about a Fourier theorem. Fourier theorem. So the resultant of first 15 terms of an equation, this is nearly approaches square wave but not exactly a square form. Approaches square but not exactly square form. If you added more and more terms, give a resultant curve nearly approaches a square wave. So that is here we are going to explain of a square Fourier transformations. So it's about Fourier transformation. It is a very important concept for 8 marks question, full marks questions. So and also very simple. Here only the mathematics terms. We are going to calculate the constants of a and b. Write it to show it. The waves are comes in a square arm, resulting of different wavelength range of radiations to get the addition of square wave functions. This concept here we are going to refer using a Sundarajan book. Sundarajan is the author book through a college physics, and also a Subramaniam, very good scientist. He has also written one book, that is a textbook of physics, So I referred this book also, and also the three prescribed textbooks belongs to Tumakuru University, Mangalagauri, Nagbhushan, and Ramakrishna sir. So from these both three books, I referred to get the Fourier theorem concepts. Also, it is a very useful concept, and also very important concept to get a very good marks. Because it is a 8 marks questions. Please refer. Don't neglect. Follow this concept to get the well, because it is a very simple addition and integration and diffraction concepts. Very simple concepts is there, so you can get the full marks in this part. It's about Fourier theorem. Thank you and all.